You use the red node, and I show you how to create a building in Blender with geometry nodes. Or use the blue node, and you wake up and create whatever you want to create. Hey everybody! So I had a chance to take a look at the Matrix Awakens, which is an Unreal Engine 5 tech demo, and it just blew my mind. Just to think about all of that stuff happening all at once, I love that kind of stuff. I noticed in the tech demo that a lot of the buildings were repeated, and if you think about them, they're really just one basic function that has all sorts of different parameters that you can play with to create many different kinds of buildings. So I'm going to do the simplest version I can come up with in Blender so that I have a flexible building to play with. So let's make our own piece of the matrix.
We're going to delete the default cube, create a plane, go into edit mode, rotate on the x-axis 90 degrees, then grab it on the x-axis 1 unit, grab on the z-axis 1 unit. Then we're going to move our pivot point to be from the 3D cursor, and then scale 0.5. And back to object mode. That creates our first wall panel. We'll duplicate on X 2 units, then do it again, and that gives us 3 panels to work with. I'm going to put the shader editor in this bottom section here and create a material for each panel. The first one I'll call ground floor material, and I'll give it a color. And in order to see this, I'm going to switch to viewport shading. Then I'll check my second panel, call it mid floor material, and give it a nice color. Then do the third, call it top floor material, and give it a color. And there I have 3 materials and 3 basic objects. The materials and the object modeling does not matter, so I'm just going to be really quick with this modeling here. First I'm going to do a loop cut with 2 slices. And before I go back to scaling, I got to get out of my 3D cursor. So I'm going to switch back to median point, and then I can scale on X to spread those slices out. Switch over to wireframe mode so it's easier to see what's going on. Then I'll do a loop cut, slice it into 3 sections, drag them up. Using Alt-click, I'm going to select the middle line, grab it on Z, and bring it up. Select the third line, grab it on Z, and bring it down. Switch over to Face Select, select this top section, and I'm going to use E to extrude. Then switch back to Edge Select, grab it on Z, bring it down. Select both the left and right sides of my awning, and use Scale on X to scale them together. Back to Face Select, I'm going to select this big window panel, use I for inset to draw it in. Then I'm going to select the 4 surrounding faces and use Extrude to pull them out, just enough to give me a nice little shadow. And that's my little ground floor shop window with awning. You can come back and refine it later or change it to something else. It's just got to visually tell me what the ground floor is. Let's dig in on the second panel. This is going to be for my mid-level floors. I'm in edit mode. I'm going to loop cut and create 4 sections. Hit escape to keep them where they started. Choose the left and rightmost and scale them out on the x-axis. Choose the center 2 ones, scale them in on the x-axis. Then I'm going to loop cut again. I'm going to create 2, drag them up high because I want that top one high. Then use Alt and click to select the bottom loop cut. Be sure to hit it on Z and bring it down. And I've got 2 windows. Switch to Face Select. I'm going to use Inset on both of these faces, pull them in, and then I'm going to select all 8 of the surrounding faces. Just like before, I'm going to extrude out on Y, and I've got something that'll create nice little shadows for my windows. Back to object mode, select my third panel, and then edit mode. I'm going to create 2 slices, keep them in the center, then scale them out on X. And then I'm going to create 10 slices using my mouse wheel to roll up, and I'm going to leave them there by hitting escape. I'm going to select these 5 faces. I'm going to use inset one more time, and then I'm going to just grab and pull them out on Y just to give them some relief. These are going to be the areas that go at the top of my building. And there I have it. All 3 of my panels are complete. If I turn on my viewport shading, I can see my colors. The next thing I want to do is create a collection, and I'm going to call it wall panels. I'm going to select all 3 of my plane duplicates, drag them into my new wall plane collection, and I'm going to rename them ground floors, mid floors, and top floors. Okay, now the fun really begins. I'm going to hide my wall panels collection, and I'm going to create a cube. Truthfully, it doesn't really matter what object you create because the geometry from that object isn't going to be used by our geometry nodes. Once I've done that, I'm going to use this bottom area here to become my geometry node editor. And I'm going to give my geometry nodes the name building. So right now, it's taking the geometry from the cube and it's placing it into what is ultimately seen and used in Blender. I'm going to start by creating a grid primitive, and I'm going to make that my output. And when I do, you can see that the cube is no longer used and the grid is. Next, I'm going to create a bunch of inputs for my building node group. That way I can control how my nodes react, make them customizable. The first one is width. It's going to be an integer. My default width is going to be 5 units. Minimum is 1, maximum is 1,000. I'm going to need one for length and height. I'll make my default length 3, minimum 1, maximum 1,000, and same with height. Starts at 5, 1, 1,000. I'll add a transform node so that I can manipulate my grid. These grids are going to be the basis for the walls on my building. If I rotate on X, you see my grid jumps to it. If I switch to wireframe, you can see how the grid is divided. It has 3 lines. I can change its size on X and its size on Y, and I can change how many dividing lines there are on X and Y. And I want these to correspond with the numbers that I input in my group that come from my custom inputs. So in order to make that work, I'm going to take the width that the user puts in for my node group, and I'm going to subtract 1 from it. But before I can use that, before I can show you how that works, I'm going to make the width and make that the vertices on the X for the grid, because that's how many panels I want to have. And the height is going to correspond to the Y. And since we're rotating our grid on the x-axis, y goes up, not out. And I got to be sure that I actually have some numbers put in here. And then I'm going to make the value for my width that's -1 correspond to the size of x. So if my width is 5, there should be 5 lines that travel across my grid. I'm going to do the same thing for the height. I'm going to have 1 minus the height, and that goes into the y-axis. Now you can see that the width of my grid is 4 units, even though the width is specified as 5, because there are actually 5 lines going across the grid, and then there are 4 lines going up and down the grid. Now I need to make sure that the grid is moved to be where I want it to be automatically. So now I'm going to take the -1 result for my width, and I'm going to divide it by 2. Since the way the grid is created has it at the center, however big you make it, it sits at the center. I need to move its pivot point to the leftmost side. So I'm going to divide by half of the width so that it moves off of its center onto its edge. So I need my -1 value for the width and divide it by 2 and then make that my x value. And then I need to do the same thing on the z-axis. So I'm going to divide by 2 for my height, that was -1. And now when I go up and down in height, the bottom of the building stays put. So now one of the problems is I have all of these little math nodes that do very simple things, subtracting 1, dividing by 2. It would be helpful, since I'm going to have to do this a lot, if I turn these into a group. So I'm going to select these 2 and Control G, and I'm going to do a lot of really simplistic math with the width and height. So I'm going to create a node group that does that math for me and gives me lots of options so that I can save a lot of space. So I want this node group to output whatever number you input -1. I want it to do a -1 divide by 2. And I want it to have a divide by 2 that doesn't have the -1. And when I return to my main node group, you'll see I now have a group that has these options that come out, and it takes up a lot less space for me. I only need 1 node instead of 2, and I can replace the other subtract and divide in the same way. So I'll clone my new node group and do the same thing. Bring height into it, put -1 into my size y, and my -1 divided by 2 into my z transform. I also want to add a pass-through. so that I don't have to split off even more noodles from my original input. So if I edit my node group, I'm going to create another value called pass-through, and I'm going to put that up at the top. And now I have the ability to make a straight line from my little math node group to my vertex x and my vertex y. And that tidies things up a little bit more. I'm also going to jump into my node group and rename it. I'm going to call it wall math. When I go back to my building, you'll see that now they're given that name. And I can collapse them because I know what they're doing. And now I can get back to work, having created my grid and transformed it to be where I need it to be, no matter what the size. So now that I have the basic wall, I'm going to call this grid my width wall, because I actually need this grid twice, once for the front of the building and once for the back. I'm going to end up using this same grid twice after doing an additional transform at another time. But for right now, I want them both in the same place. I also need a second set of grids that are going to do the left and right side of the building. So I'll create my length wall grids, and I'll copy the structure that I use to transform, but instead of using the width and height, I'm going to use the length and height. So I'm going to make a duplicate of my wall math, open it up, bring length into it. The same spots where I use the width values, I'm going to use the length values. So length -1 now goes to size x, pass-through goes on vertices x, -1 divided by 2 goes on transform x, connect my geometry, and then for the height, it's the same as the width wall. -1 goes on size y, pass-through goes on vertices y, -1 divided by 2 goes on the transform z. And you can see that the grid that I've created is as tall as the other grid, but it is only as wide as the length, and length controls how long it is. Height still controls the height. Now that these are done, I'm going to tidy things up. I'm going to rename these wall math nodes so that it's easy for me to follow. This is the wall length math, wall width math, and wall height math. And I'm going to reorder them. I'm going to take a moment and organize some of these. The next big step is to take these two basic grids and turn them into the framework of my building. In order to see both grids at the same time, I'm going to use a join geometry node and a couple of transform nodes. Every time I split off my geometry and pass it through something like a transform node, I basically clone the object. So every time I clone it, I can move and rotate it so that I can move it to where I want it to be. And what I basically want is a rotated mirrored version of my width and length grids. In order to grab hold of some of my values that I'm going to need, rather than dragging them all the way from the original input, I'm just going to clone the input. It's a handy little trick. I'm going to create a combine XYZ so that I can create my new location for translation. I'm going to use length on my y-axis and width on my x-axis. And you can see what I've got here is sort of a mirror image. I've also rotated on the z-axis by 180 degrees. Now you can see as I mess with the width and the length, these borders of my building, the front and back of my building, will move to where they're supposed to be. Then I'm going to do the same thing 2 more times. My first width wall is exactly where it's supposed to be, so it doesn't need another transform. But the other 3 sides of the building do. I'm going to create the same structure 2 more times for my length walls. Transform nodes that receive the geometry. And when I put that in, I'm going to focus just on my length walls for a moment. You can see my length wall by itself. If I mess with the length, it changes size. I'm going to rotate this length wall by 90 degrees and use another combine XYZ so that I can control its position. Put my input node in a more convenient location and put the width for X. Create another combine XYZ node. Put the length for Y and rotate it 270 degrees on the x-axis, and you can see now I have the same mirror effect for my length walls. And if I add back in my width walls, you can see the general shape of the building. And now as I make it bigger or smaller, it just scales and grows all together. Just to make things easier, I'm going to make another input group so that I can keep the length walls and the width walls somewhat separate visually. Makes it easier for me to debug later. The last piece of this puzzle is the grid for the roof. So I'm going to create another grid. I'm going to keep this exercise simple and make the vertices on x and y both 2. Basically, it's going to be a square. It's not going to be divided into any smaller parts. Since the roof mirrors the footprint, I'm going to make the width x and the length y. And when I add it, you can see that it pops in at the bottom, and it's sort of the footprint of the building for the time being. Here's where I need my divide by 2. Since I'm not subtracting anything from the length of it, I just want to divide by 2 so that instead of being centered on its origin, it's going to sit in the lower left corner. And to get that to happen, I need my trusty transform node and my combine xyz. And I'm going to use the width divide by 2 on the x-axis for combine xyz, and the length divide by 2 on the y-axis. And then I want to use the full height, the pass-through for height, so that it sits on top of the building. And those gaps in there are intentional. That's where my panels are going to hang off the edge of my grid, and they will touch the next wall or the roof. That's my basic building. And take a moment, and I'm going to reorganize this for a minute. I like to keep my lines as visible as I can make them. The roof is handled here so that the roof gets its own section, the length walls get their own section, and the width walls get their own section. And then they all get joined and they become the output. This might be a good time to put a frame around the different sections of my work. So I'm going to grab a frame and I'm going to select some of these sections here and put it inside, give it a nice color so that it stands out. I'll place my roof inside of the frame as well, and my grid transforms for the basic grid, because this is where all of my grid creation happens. I'm going to give my frame a title, make wall grids, and now we can dig into the last part where I'm going to apply the panels that I made at the beginning so that it decorates my building frame. Now I'm going to finish off my building by applying the panels that I created at the beginning. And in order to focus on this, I'm going to move my output down to the bottom where I can just take one width grid and focus on that. So we're going to use instance on points to place each panel on each point on the grid. And we're going to choose from my collection info node, which I'm going to set to my wall panels and then attach. And when I do, you can see I get a whole lot of crazy stuff happening here. First, I want to separate children and reset children. Doing so means that no matter how I rotate or translate my panels, they will not show up at their rotated position. I'm also going to choose pick instances, which allows me to use data to figure out which number in my collection I want to use. Instead of throwing all of the panels up on each point, it chooses only one based on a number. So if I choose this integer selector, just as an example, if I choose 0, you see it chooses my ground floor. And ground floor is 0, mid floor is 1, and top floors is 2. So when I change that number, I get a different selection. So whichever number goes into instance index, that's the number in the order of my wall panels group that it's going to select. One thing to note about this, the reason I chose the words ground floors, mid floors, and top floors is because alphabetically they line up the way I want them to. I want the ground floor panel to be 0 in the list. So it has to be the first one on the alphabetical list. Mid floor needs to be the second, and top needs to be the third. So if I had chosen different words, they might not have worked. If later I go back and change the name of my panels, I might screw up my building. So it's important to keep track of that when you work with collection information. Okay, so how do we have the computer choose which panel we want to use for what floor? This node group that I'm creating is going to take in the height that gets passed from the original node group as an integer. I don't really care about the defaults because it's always going to receive something. I'm going to create one for the ground floors and one for the top floors. Basically, how many floors are going to get the ground floor treatment and how many floors are going to get the top floor treatment. Now, in order for this to work, my original input has to be updated. So I'm going to go back and add ground floors and top floors to the original building node group. And I'm going to connect that height, ground floors, and top floors to my new node group. When I go back into my node group, now I can use those values. I'm going to get rid of my little integer helper here, and I'm going to use the transfer attribute node. Basically what I'm saying is I want to get the value of each point on the grid that corresponds with its position. So I'm putting the position node in, and what I get from attribute out is just going to be the XYZ values for each grid point as they're processed. I'm going to separate the XYZ, so now I can look just at the z-axis going from the floor up to the sky. And basically what I want to say is, if the z point is below a certain point, I want it to get a value that gives it the ground floor. If it's above a certain point, I want it to get the mid floor or the top floors. You can see when I apply the z value to the grid, it counts up from 0, which is my blue ground floor, to the orange mid floors, to the green top floors, and then it loops. So I'm using the position of the points on the z-axis to choose from a list inside the collection. I'm going to use a math node that has greater than so that I can compare the z value to a number. What I really want to do is compare the z value to the number of ground floors that I want to have, which right now I'm going to set to 1. Notice that the ground floors are a little off. I actually need them to be -1 in order for this to work. So I'm going to subtract 1 from my ground floors and then compare it. And when we use a little bit of math, I get ground floors 1, 2, 3, 2, 1. Now they work the way I would expect them to. So if the z-axis on the grid is greater than the ground floor that I want, it means the number 1 comes out of my greater than node. If it's less than that, I get the number 0, and it chooses my ground floor panel that's in the 0 position of my wall panels group. So I'm going to take this one step further to create my top floors. I'm going to create another subtract node, and what I need to do is I need to count down from the top. So I'm going to subtract my top floors from the height. Just like with the ground floor, I need to add something to it in order for the numbers to work. So I'm going to add 1 to the ground floor and then subtract that value from the height. And if I look here, you can see that now I will count down. One more time, I'm going to compare this number to the z value. And now you can see that I can count down from the top. The greater the number, the greater the number of floors at the top of the building. But it's still choosing between 0 and 1. So what I'm going to do is now add those two together, and then take that value and make that my index instance. And now it works the way I want it to. If it's the ground floor, it gets a 0. If it's a mid floor, it gets a 1. And if it's a top floor, it gets an additional 1. So it becomes 1 plus 1 is 2. I'm going to reorganize some of my inputs here so that they're easier to play with when I leave. And they look kind of nice here. I'm going to take a moment and rename this group that I just created to apply panels. Now it'll be easier to understand what's going on. Since I created all of that work inside of a group, I can just use it again on my other wall grids and just bring the height to the height, the ground to the ground, the top floors to the top floors. And when I reconnect all of my grid pieces, you'll see that it starts to apply my walls to the front and back. Oops, I've got an extra grid here. Get rid of that. And now you can see that I've got panels applied to my front and back. And if I change the ground floor and top floor, it changes the ground floor and top floor on both of them. The next step is to apply my panels to my length walls on the left and right side of my buildings and connect my height, my ground floors, and my top floors to the appropriate inputs, and then do it one more time. And my building is basically complete. And then just bring over that roof from before, and there's the top of my roof. And now I can make my building grow or shrink as I please, and it looks like some kind of high-rise. Move my light out, change the shading. This is always the best part, when you can play with some of the parameters and the building just modifies itself. Now I'm going to take a moment and focus on organizing my nodes. I think sometimes there's a fine line between organizing them and getting a little OCD about them. You want them to be visually easy to navigate so that you can debug, fix problems if you see them, but at the same time, you don't want to lose too much time organizing your nodes. Okay, organized my nodes. I'm going to finish off with a frame for this second part of my building. Give it some color and a name. Call this build width walls. Select all of these nodes, put them in the frame. Build length walls. Keep my noodles free so that you can see where they're coming from. Pretty neat and tidy set of nodes. And now my building is packaged and ready.
Well, what color should I do? Well, I mean, it's the Matrix. It's going to have to be green. Oh yeah, has to be green.